Access to quality, nutritious food is fundamental to human existence. Food insecurity is a severe problem that affects 1 in 3 humans around the world. And the recent disruptions in the global supply chains have highlighted the turmoil that lack of access to nutrition can occur to anyone in the world. We plan to help reduce the drastic effects of a sudden disruption in the global food supply chain by training a machine learning model to predict the supply of primary crops with factors of production, land, and labor as our predictive variables. We can use this to help countries that rely on India and China as their primary supplier of crops to forecast their food inventories and anticipate any further disruption. From a list of 12 datasets, we have decided to choose our following datasets as our predictive variables. Datasets used. Mean annual temperature. Too high of a temperature may cause droughts, which will kill crops and reduce crop yield. On the other hand, too low of a temperature will affect rate of metabolism and growth of crops. Fertilizer consumption. The addition of fertilizers compensates the deficiency of the soil. This will affect the growth and development of crops, thus affecting crop yield. Total population. Total population of India and China will be used to estimate the available workforce for the agricultural sector. Cropland. The land size used to grow crops. In this code block, we import the necessary libraries. In the next code block, we read the CSV file into a data frame and display it. In the following code blocks, we plot a scatter plot with each of our predictive variables as the x-axis and the total production of crops in each country as the y-axis. We do this to establish that there exists a strong linear correlation between the predictive variable and the outcome variable. Features and target preparation. In the features and target preparation part, we first include the functions which will prove useful in later stages. Normalize Z. Function takes in the data frame and returns a copy of a data frame with all the variables normalized along the column. Get features targets. Function takes in the data frame and column names and returns the required columns. Prepare features. Function converts the data frame into a NumPy array and changes it into a column vector. The function also adds a column of constant ones to the first column. Prepare targets function, which takes in a data frame for the target. This function converts the data frame into a NumPy array and changes it into a column vectors. Split data function creates a function to split a data frame randomly. MSE finds the mean squared error between the two functions. R2 score finds the coefficient of determination between the two datasets. Compute cost computes the error caused by difference in our predicted dataset and our actual dataset. Gradient descent returns new beta and cost and is used to find the minimum cost. We define the predictive variables in a column, prepare the target and feature data frames, and call the split data function with 0.9 as test size. We normalize the features and call prepare functions and prepare target function for a number of iterations and call the gradient descent function. We use this model to call the predict function with a data frame and plot R square to find the correlation. We do the same process for the next country. We observe that the R square value for China and India models is 0.3009 and 0.368 respectively. Let us see how we evaluate a model. MSE for the two models and get 0.0388 and 0.007363 as the MSE for India and China crop production. Since we have a low coefficient of determination, let's look at how to improve our model. Improvement 1. To better our model's performance, we can split the dataset more evenly to reduce the overfitting of data values, which occurs when our dataset is limited. Changing test size to 0.4, we are able to improve R-square values for our models for China and India to 0.88 and 0.9334. As you can see, this is a significant improvement from the previous model. Improvement 2. To further improve the model's performance, we can change the alpha value to 0.01 and increase the number of iterations to 1500. Cut. To further improve our model's performance, we can change the alpha value to 0.01 and increase the number of iterations to 1500. This marginally improves the R-square value of our models. Discussion and analysis. After modeling the different variables, fertilizer consumption, mean temperature, total population, cropland, we were able to see the linear relationship between the agricultural factors of production, land and labor, and the net production of crops in China and India. This model can help predict net crop production according to changes in these variables. We can conclude that with an increase in the predictive variables, the net production of crops will increase. As you can see from the above outputs, the model has a coefficient of determination between actual and predicted crop production as 0.88 and 0.93 for China and India models respectively. We can also observe that the mean square error is 0.0042 and 0.11 for India and China models respectively. From this, we can conclude that our ML model has high chance of predicting crop production output accurately. Our model certainly has some limitations. Firstly, there is a data limitation due to insufficient data available. Our model does not consider other predictive variables which may have more significant impact on the production of these crops. We were unable to find the data on certain variables such as the amount of rainfall and the amount of water used for irrigation. Secondly, our model cannot take in extreme values. For example, too high for temperature will kill the crops, as crops are unable to thrive in such conditions. If the total population is too high while the percentage of agricultural workforce remains the same, overcrowding can happen, which will eventually reduce the net crop production due to limited land to work on. This concludes our presentation. Thank you. I'll pass it on to Yash for the website.
To our website. So as soon as we load our website, we see a food security heading. We also have our navbar, which is actually a bootstrap navbar. Now we have added custom hover effects to each of them, and we've also added an on-scroll function to the entire navbar. We also have an anchor tag down here, which basically redirects you to our problem statement, along with a few of the challenges that are faced by the world population right now with respect to the topic food security. We've included a few infographics in the carousel here so that the user can get a quick and rough idea of what actually we're talking about. In our About Us page, we have a short description about our contributions, and if anyone wants to go through and actually get to know us better, our LinkedIn profiles are also linked in the LinkedIn tags. We have used Type.js to create the typing animation on top of the screen, which gives the user more for interactive feel. The reason why we actually placed a modeling uncertainty page as well was to ensure that the professors and any user reading can actually get a better understanding of our design thinking process. Also, we have provided a short summary of our report and our Excel sheet, including our dependent variables, independent variables, assumptions, and graphs, so that the entire user experience is much better. If any user decides to go in more depth, we have provided our resources that are our report and Excel sheet, along with our references. Now, for the DDW page, we have a video, which will essentially be the video that you're watching at the moment. We've posted pictures of the code essentially, and given a brief explanation of what the code does. Along with that, the way we've divided it is so that each function is explained to a certain extent in a brief and quick way, so that the user has a rough idea of what exactly we are doing through this project. We have our predicted models. Along with that, we have documentation and our Google Drive link, which will contain all the files to our project and all the CSVs that we have referenced. We also have references to a few other resources that we have used throughout this project. Thank you so much for your time, and hope you enjoyed our short video and our project.